Hello to everyone, and thank you so much for joining us for our June Detect to Protect webinar. My name is Kim Schofield. I'm from Stamus Networks, and I'll be hosting the webinar and managing any questions that you all may have at the conclusion of the call. So today we are very excited to have two of our technology partners joining us. We have NetQuest and Garland Technology. And so we're going to have three presenters today. We have Phil Owens. He is our Vice President of Customer Solutions at Stamus Networks. Chris Bihary, CEO and co-founder of Garland Technology, and Stephen Shalita, Vice President of Strategy and Business Development at NetQuest. So just want to remind everyone that today's webinar is being recorded, and a link of the recording as well as the slides and additional materials will be emailed out to you early next week. If you have any questions during the webinar, we would ask that you please hold those until the end of the presentation and then type them into the Q&A window, which can be found there at the bottom of your Zoom screen. So with that, I am going to go ahead and hand things over to Phil, I believe is going to start us off.
Excellent. Thanks, Kim. Thank you for that introduction. So as Kim said, I'm joined by a couple of our business partners. We really like Chris Bihary and Stephen from NetQuest and Garland. And today we're going to talk a little bit about East and West traffic, right? So we've already gotten the intro. We're going to talk about monitoring the network, as well as how to configure an infrastructure to be able to handle what would be known as east and west or lateral traffic. All right, if we move on to the next. Network visibility is critical for an enterprise security solution. So as you're building out your enterprise security tools, we do believe that network visibility is one of those critical pieces, and I'm going to explain why in the next couple of slides. So why do we monitor the network? The main reason to monitor the network is there could be things moving around, and there are lots of ways to monitor a network, but the bottom line is, or monitor your systems. The bottom line is there's the truth in the network, right? So really, even things that you can't monitor, you can't put an endpoint agent on things like network infrastructure, things like IoT or OT type of devices, bring your own devices in areas like that. You really can't have an endpoint solution on there to be able to see everything that's going on. However, you can see the network traffic that's being delivered through those devices. So can you move next, Mark? Thank you. So some of the attack signals that we're looking at is network intrusions, C2 communications, where there could be communications backwards and forth, lateral movement, east and west traffic that we've talked about, as well as data exfiltration. So when data is leaving the network, and you don't want to have those pieces happening. Another piece of interesting information that you can get from the network is hygiene of the network, right? Possible unauthorized access, shadow IT. Real key player is policy violations, things that you have turned off in the network, but you actually are starting to see it. So being able to be able to see that information is very, very important when it comes to actual network hygiene. Something I want to also point out on this is that from a security perspective, monitoring your network is going to give you an idea of what your network looks like. And what your network looks like is one of your biggest defenses against an adversary, right? You understanding your network is a big defense when it comes to understanding how an adversary might be trying to get in and building out those defenses. Next slide. So here we can see a couple of recent articles that have come up with regards to evading EDR. There's a book, as you can see. So we don't want to say EDR is bad, because it's not. I believe in EDR. I think it's a great solution. But we have noticed that a lot of the big players and a lot of the APTs out there have spent considerable amount of time in trying to evade those types of detections. I do believe that having that information from an EDR can help identify threats so much more, and that we add to that from a network security perspective with the data that's being delivered off of the network as well. So being able to see the communications and then diving even deeper to understand what processes on a device might actually be doing those communications. So here we can see, like I said, a couple of well, at least one relatively recent articles as well as a book that you can buy on Amazon, I believe. So we're starting to see a lot of expanding agentless attacks, and really what that means is attacks on machines where you can't put agent software. Again, I mentioned some of these previously with the bring your own devices and Internet of Things. So IoT, network devices. In the next slide, I'm going to show you that there's been a lot of focus on network devices, as well as operational technology. Medical devices where things have been hardened and can't be touched. You can't add updates to them, so they stay in a constant configuration that might not be advantageous from a vulnerability perspective, as well as in for instance education areas where Google Chromebooks are utilized. Putting an agent on those is pretty difficult. So as I'd mentioned, some of the attackers are targeting network infrastructure, especially the network infrastructures that have OSs on them, and they can get around. And here we can see some really recent targets around that with regards to Cisco's ASA, as well as FortiGuard and Avante Connect Secure VPN, things that have just happened recently. And these are appliances that a lot of times will have a full OS on them, but you are not allowed to actually put an agent to them. So that means you don't get all of the visibility from an agent perspective that you might otherwise see on a standard server or a client device. So some of the requirements from a network security monitoring perspective is you'll see here we have network taps and mirror ports, which will be talked about pretty extensively as far as the architecture is concerned, coming off of corporate headquarters, and then a sensor or probe for doing deep packet inspection. And I'm a huge advocate on deep packet inspection versus just flow records, right? Flow records get you some data, but being able to do full deep packet inspection will get you information, around that flow data, information of the body of decrypted sessions, as well as other items that you wouldn't just see in flow records only. So being able to do deep packet inspection. Sending this information up to a central analytics and management solution and being able to manage all of those probes or sensors across the network, very important from a requirement on a network security monitoring perspective. Doing alert triage and prioritization, and being able to connect with the rest of your security stack, also very important. Network security monitoring shouldn't be your only monitoring tool, but it is definitely something that you're going to want to be able to connect in with the rest of your tech stack, moving information into a data lake or being able to send messaging alerts over to a SOC. You're also going to be looking for something that can handle multiple detection mechanisms, not just AI type of mechanisms, but also, even rules and signatures, AI, stateful logic, any different ways of being able to do detection across all of this network traffic that's coming in. All right, so now I'm going to move over into more on the east-west side of monitoring traffic. So if we hit the next slide, just real quick from a definition perspective, north-south typically means ingress and egress, or egress and ingress, right? So coming in and out of the network, maybe even good network, bad network, as I like to call it. And then east-west traffic, also known as lateral movement traffic. And what we've noticed is historically focus has been on a perimeter, and that perimeter is starting to change, right? Where the perimeter looks more like less like a perimeter. Historically, we had a hard, crunchy outer shell that we were able to protect, but then once people got inside, it was a warm, gooey center, right? So if an adversary gets in a situation like that, moving east and west across the network may be a little bit easier for them. So the key here is to be able to actually monitor that traffic going east and west or laterally on the network. Many breaches have revealed successfully breaching a perimeter, gaining access, and then going undetected, mainly because of the complexity possibly of actually being able to monitor all of the traffic moving through your corporate network. So some of the benefits, right? We have deeper threat detection. East and west monitoring allows for spotting of lateral movement. This tactic uses maneuvers within the network, right? So the attackers could actually utilize normal tools, but you would be able to see what's happening and if things are happening from a area of the network that it shouldn't be. So you can also start to monitor insider threat visibility. Are some developers on the network accessing finance systems that they shouldn't be, and being able to see that information from an insider threat perspective. Data exfiltration, right? East and west monitoring allows us to see what data is being looked at, as well as exfiltrated, as well as getting that information north-south and where it's coming from. So if the data shouldn't be coming out of a certain area of the network, you're able to see that with this type of monitoring. The other thing that we like to talk about is a lot of people are doing microsegmentation as well as zero trust security, and that's great. But I always go down the path of the old saying of trust but verify. And monitoring the traffic with deep packet inspection allows you to do that verification and making sure that authentications are happening in the locations of the network that are required. And then also by having that internal network traffic available to you, you can make incident response faster. So you're quicker to respond to items because you know exactly where to move to see the information. So what I'm saying about that is, if I'm looking at all the traffic between the networks within my organization, I can actually move around and understand where an attack is taking place on the network, as opposed to the bigger just north-south traffic. All I know at that point is that it's happening in the network, not exactly where in the network. So some of the things that you can uncover looking at lateral traffic, here's a quick screenshot of some information, right? Being able to see a timeline of events and where lateral movement may have taken place. And here's some Cobalt Strike was utilized. There was some base 64 encoded executables taking place. But if you look at that vertical line on the center of the screen there, you can see we're actually able to show you that there was a movement from 10.44.65.43 down to 10.44.65.18. And that could be a client machine trying to talk to a domain controller in a way that shouldn't be done. So other types of activity from east-west traffic: insider misuse or privilege access. This goes back to zero trust, right? Making sure that the people who have access to certain parts of the network are the only ones getting that access, and being able to verify that that's taking place. Compromised server communications. So if the server starts to communicate, possibly doing scans across the network that it shouldn't be doing. Even spoofed communications within the network. So people, legitimate devices within the network gaining unauthorized access by trying to spoof network communications. And then also, once in, possible denial of service, maybe even encryption of data that could be happening from a piece of ransomware, for instance. A recent breach example. Operation Midnight Eclipse, right? That's what it was dubbed, and it was a Palo Alto vulnerability. Again, this goes back to network infrastructure being targeted, and this is relatively new back in March. So the infrastructure in play here was a Palo Alto device, and the threat actor actually went around and tried to place 0-byte files on firewalls to find out if they were able to exploit them. And then as soon as they got a decent list and got things in, they actually moved very, very quickly, which made it very clear that this was a highly capable threat actor with regards to moving laterally within the victim's networks after getting onto the device that should be protecting that network. All right, so I want to turn things over to my friend Stephen, as well as to Chris, to talk a little bit more about the architecture and challenges of moving capturing east and west traffic and how to go about doing that. So Stephen, all to you now.
Great. Thanks very much, Phil. All right. So I think Phil provided a really good overview of what we need to do in monitoring east-west traffic. The Midnight Eclipse, while it wasn't a big, widespread breach, it really focused on a couple of key companies. It really illustrates the importance of east-west traffic observability, because they breached the perimeter, they got inside, became trusted, and accessed all the resources and created all of these challenges. So the analytics value that Phil's just gone through, being able to understand everything that's happening in the network environment and identify and observe these things, is really dependent. It's predicated on the completeness of network traffic observability, being able to see that traffic that's crossing the network. Arguably, network intelligence, the intelligence you're able to glean from network traffic, which is all of your data in motion, all of your user activities, is the most valuable set of insights that you can use for threat hunting, breach detection, and being able to mitigate that breach activity. All of the other pieces, as Phil said, are important. Endpoint, dealing with the perimeter, and having that visibility. It's a multi-point world today to be able to stay ahead of these threat actors who are very good at breaching, at navigating and finding vulnerabilities. So network traffic gives that ability to see everything that's going on unencumbered. Log files only provide you snapshots in time for a particular device. That doesn't piece together the full communication and interaction between devices, users, inside, outside the network. So being able to see east-west conversations, the communications between servers, is very important because it helps you identify the vectors that are used to move across the network environment. Right? Keep in mind, with segmentation, as Phil talked about, that traffic typically becomes trusted once it's allowed to move laterally across the network. Once it's trusted, no one's thinking about the potential risk. Well, someone could have spoofed or gotten credentials from someone else, as in the Midnight Eclipse example, and move unencumbered, uncontrolled across the network environment. So what you're looking for is anomalies within that environment to say, hey, this is not normal behavior, and that's where the analytics comes in play. But the analytics will miss that without the visibility piece. The other area, and we're going to talk a lot about that as we kind of dig into the architecture, is dealing with encrypted traffic and other challenges of that traffic that's flowing across the network that you're not able to get visibility inside. But the goal here, and we can move on to the next slide, Mark, is to be able to get visibility across the network environment from north-south, what's moving in and out from users outside of the network, what's coming in from the outside, because that's ultimately where the bad actors are going to take the traffic, but being able to see east-west. And the challenge that we have in driving that visibility across the east-west environment are really three key things. One is coverage. You're talking about a significantly higher number of visibility points that you need to reach. It's not just tapping the WAN link or the connection that's going out of the network or to the other data center. I now need to look at all of the cross communications across the servers. Doesn't make sense to get visibility down into the servers themselves, but we want to look at aggregation points. The speed of those connections are constantly growing, and we'll talk more about that. Traffic within the servers. So getting the coverage is challenge number one. Number two is the scale and the capacity to be able to deal with the amount of traffic that needs to be monitored. Doesn't matter if you're a medium-sized enterprise, super large, or even smaller, your data traffic is growing at unprecedented rates. Orders of magnitude more traffic, speeds of the links are increasing. 80% of the traffic within the data center is traveling between servers. So it's not even leaving the data center environment. And that servers can be including enablers and enabling technology, DNS, DHCP, other functions that are all part of that communications environment. So what we see is the traffic volumes that are happening in the network are outpacing the processing capabilities of analytics and security tools. And even if you're collecting and storing packets, the ability to store that over a reasonable period of time. The third area that really is a challenge is how much of that traffic that you're able to see is truly monitorable. I'm going to keep mentioning encrypted because that's one of the biggest, if not the number one challenges after, probably number two after the scale and the speed and the volume of traffic to monitor. But a significant amount of that traffic is low value. It's not very useful to monitor it because we can't get anything from it. So we need to be able to see the interactions between users and systems, but we have to get across the challenges of, can I monitor that traffic and get something out of it? So as I build this architecture, the fourth area that's a challenge is the cost of infrastructure. Being able to implement visibility across that east-west environment, across all of the server infrastructure and enabler infrastructure, becomes more and more expensive. It's not as simple as putting a probe or a sensor or a monitoring point at one or two ingress-egress points for redundant WAN links. You now need to get much deeper visibility. And we'll look at that from an architectural perspective, but I've got to get more probes in more places and deal with this traffic increase, the number of links, the higher speed links. So fundamentally, the challenge that people face, let's say we get past the coverage and everything else, the cost and complexity of building that visibility architecture is a challenge. And that's what we're going to look at here as we look at ways of getting the most valuable intelligence from the network that we possibly can. So we'll start with that. And Chris will talk about kind of the foundation. Then we'll come back and look at the architectural implementations of that. And then how do we deal with all this traffic volume?
Excellent. Thanks, Steve. Thanks, Phil. Great to be here today. And appreciate everybody taking the time out of their day. I know everybody's busy. And so look forward to continuing to dive into how to get traffic from the network, talking about aggregation, wiretapping, and Mark, if you don't mind going to the next slide. You saw a sneak preview of that prior, but I'd love to say that the truth is in the packets. And Phil mentioned it earlier, right? There's different strategies of NetFlow and things that you can do, but we're a big believer in the fact that you really need to get packet level data, and a lot of companies really do have visibility at the north-south side of it, but really haven't dove into moving to the east-west traffic to get covered. So we're seeing more and more in this, and more companies taking this initiative. And for us, when you're looking at deploying security tools, you want to find out what's happened in the past, what's happening currently today. It's important that you have a strategy that allows you to get packet level data to your security and monitoring tools. Can you go to the next slide, Mark? So at Garland, one of the things that we really focus on is what we call the tap the tool philosophy. And what we look at doing is finding ways to instrument your network so you can effectively get packet level data really anywhere in your network, depending on what type of security and monitoring tools that you're trying to deploy. And do that in a non-intrusive way where we can get traffic, aggregate it together, and be able to deploy it to your security tools and monitoring tools. So If you haven't worked with network taps, I'll just tell you a little about that. So a wiretap, is a unmanaged device that allows you to get traffic from a link. So if we use an example of, let's say, you have a router switch, or you have a switch server or switch environment. The way a wiretap works is, let's say it's a 10 gig link, and you currently have 2 switches connected with a multi-mode short range connection. When you insert a wiretap, you would disconnect that cable, take the switch into the tap into the other switch, and you don't change any configurations. There's no IP address, no MAC address, completely passive. And the job of a tap is to copy every packet. So, Phil and I are having a conversation. I put in a wiretap in between us. It's going to repeat everything I say and Phil says. So the idea here is that you have a permanent device, unmanaged. You don't have to change any configurations on your network, and it's going to copy every packet over. So if you tap a 10 gig link, it can copy up to 20 gigs of traffic, since in a full duplex environment, when you have, if you were to have 100% utilization, which generally you never see in a production network, but you have traffic flowing, from switch 1 to switch 2, 10 gig, and switch 2 to 1. So that's why when you're looking at putting a tap in, you have the capability of getting, full, getting the full traffic, full duplex traffic copied over. Next slide, please. So when you look at the architecture here, for out-of-band monitoring that we're talking about today, so, Stamus Networks and working along with NetQuest, we put in an infrastructure where, maybe today, you may have wiretaps, at north-south, but really moving, down to your east-west traffic of looking at, inserting wiretaps, permanent. They're there, 24/7, 365, copying all the traffic. And, when you look at tapping that infrastructure, it's going to be a much higher density number of taps that you're going to require and number of links that you're going to tap. So with that, if you put in a basic wiretap, each tap creates 2 monitoring ports. One of the challenges you have is, how do you take all these monitoring ports and be able to collect that data and get it to Stamus Networks, or get it over to NetQuest appliances. So the wiretap infrastructure that goes in, it's important that you then look at putting in an aggregation layer. So as shown in this picture here, you have a packet broker. So we're taking the outputs of all the taps and bringing that into a packet broker. So think of that as, bringing that into a central location that gives you full access to the traffic. And then from there, you can send that traffic and to your Stamus appliances, to NetQuest, but you can also send it to perhaps other performance monitoring tools or other security tools that you want to deploy. So the beauty is, once you put this infrastructure in, this is permanent placement, and now you're going to have full access to the traffic. So you think about the power. I started off with saying, the truth is in the packets. So what you're putting in here is a permanent infrastructure that is now allowing you to have full control, full access of everything that you're that's traversing over your network. So for us, it's important that we look at this, and it's not just for the initial deployment, but it's giving you that full access all the time to this traffic. And so it's important that when you're looking at this design, that when you move to east-west, as Steve mentioned, right, it's going to be a lot more links. So it's important that you also put in an aggregation layer, packet broker layer, so you can effectively monitor all that traffic. Next slide, please. So if you're not familiar with Garland, this is our core focus. So we focus on network taps, data diodes, packet brokers, bypass taps. And our goal is really simple, is that, right, we want to be able to instrument the network in a very cost-effective way where you can get all the packet level traffic to your tools. So for us, we don't make performance monitoring software. We don't make network monitoring software. And, this is why, it's really important for Garland that we team up with companies like NetQuest and Stamus, so we can help provide the infrastructure for them to do their jobs to be able to get this traffic. And, as part of that, we really believe it should be simple, it should be easy, it should be cost effective. And when you look at our approach, with our packet brokers, we don't do any, licensing fees or port fees or feature fees. So again, our mission is really looking at how can we effectively get the packet level data, to a central location, so you can truly have, the power, on your security team, but also on your network performance team. So if you need to troubleshoot, why is there performance issues, the beauty is the taps are in place, the packet broker aggregators are in place, so you have full access to that. So when you're looking at deployment, Steve mentioned it does, can increase the cost when you're going east-west because of the number of links. But, think about the power in the other group. So, if it's, currently mainly, security folks on the webinar today, this is an area that you can also look at saying, hey, can we get networking involved as well? Because they can also, use this traffic for performance monitoring and really leverage that. So, it could be, looked at as, additional budget dollars being brought in to, to help, deploy and, pay for these systems. Next slide, please, Mark. So Steve's going to jump into a little more detailed architecture on this for east-west monitoring. And Steve, pass it over to you.
Great. And to build off your point, Chris, I mean, there was a recent market report, so I don't remember which analyst, but somewhere in the neighborhood of 60 to 75% of the traffic that's being collected from the network, from the tap into the packet broker, is being shared across multiple platforms, from the performance management side to the security side. So really the goal here is tap once, build a visibility infrastructure that can feed across your entire organization, whether security and performance are separate teams, they're all working from the same data. And you're really only going to be able to tap once and then regenerate that traffic to multiple devices. And that's where the Garland architecture fits into that, if you progress to the next slide, Mark, in being able to provide that access to the packet traffic, which is critical for both security monitoring and performance monitoring activities. As I said before, network intelligence is the most valuable set of intelligence that you're going to get within your infrastructure. It's more expensive in the sense of getting that, both in the sense of the infrastructure to build visibility, but also how do you deal with that volume of packet traffic? And so between the Garland infrastructure and the NetQuest infrastructure, we enable you to be able to access that traffic very efficiently, to be able to deal with the large number of links. If we look at the picture in the center, and I'm going to drill down into that, we've got to get coverage across the entire corporate network environment to really understand what's going on. We need access to all different kinds of speeds, whether you're evolving your data center from 1 gig connections to servers. The majority of data centers today are 10 gig, 25 gig to the servers. And we'll look at that in a little bit more detail. But how do I get access to all that, normalize that traffic, and then efficiently feed it up into the analytics layer? That upstream set of tools that's leveraging all this data is key. Chris talked about the TX and the RX, the transmit and the receive side. All this network traffic is full duplex. You have traffic running in 2 directions. I need to be able to capture both of those streams to be able to feed it up to truly understand the conversations. And at the analytics layer, we need to know where that traffic came from. Did it come from the transmit side, the receive side, what link? So being able to identify the source of all of that, collect all of the tap environments, and spans for where you're doing on-demand monitoring. Tap is your much better solution for full-time monitoring. It's least intrusive. It's not going to impact your network infrastructure. But how do I get all that information together, collect it, combine it, and efficiently deliver up into the tool environment?
Yeah, and Steve, just a comment, Steve, too, on that. as you mentioned, it's, I generally see that, becomes a mixture of tapping and spanning, right? And you want to, you want to get some internal conversations and switches that, so, a lot of times it's a combination, but I always like to bring up, there was a great presentation. Rob Joyce was just recently retired as the CISO, and he did a public presentation talking about, one of the worst nightmares of a hacker is putting in a wiretap. And the reason for it, right? Invisible, don't know it's there, don't know you're monitoring, no IP, no MAC, and so for me, a lot of it's strategy and continue to look at span you can turn on, a lot of limitations and some risks there. But for companies to always be planning and looking at, especially in this presentation, east-west of where you can strategically continue to grow your tapping infrastructure, because once it's in, right, as you know, Steve, it's permanent, and you're then guaranteed every packet. So I always like to say it's a journey, and to continue to look at building that infrastructure when you can.
Absolutely. And it's worth a follow-on conversation with anyone looking at building the visibility environment, how you architect this, if we go to the next slide, Mark, and what we need to do to be able to manage all of that traffic, tap versus span and all of those things. But if we think and look at that network architecture as an example, now everyone's environment is different. You certainly have certain services that are sitting in the cloud, and there are ways to look at that next. If we think about the east-west side, next, Mark. We think about the east-west side, where we need to get visibility is across that server infrastructure, so we can see all the lateral communications and communications between servers, enabler functions, user-to-server communications. This is where we're going to catch the bad actors exploiting different aspects of the infrastructure. In most cases, that traffic is going to be trusted. So you're not looking for that. You're going to look for things like login failure attempts and other things that the analytics are going to see. But analytics isn't going to catch that, isn't going to be able to see that without the visibility at this layer. And this is where you really want to implement permanent, full-time visibility that feeds up into the analytics layer. And we'll go a little bit deeper into that. But we're looking at east-west, top of rack, end of rack, aggregation points to see that lateral traffic. Typically going to be 10 gig, 25 gig, 40 gig links. Can you go back, Mark? Then go ahead with the progression. Then we want to think about that north-south. And north-south is also very important, and that's your starting point, really, to have the visibility here. Here we're going to see authentication. We're going to see data movements in and out of the network. We'll see non-standard traffic patterns. You can catch DDoS types of activity, but you also can see the reconnaissance activity. If you go back to the midnight eclipse example, there was a lot of activity that would have been observed between these two tiers of the network environment that would have given you indication that there was nefarious activity taking place. As we look at those types of links, we're typically looking at 40 gig, 100 gig. Again, everyone's network's going to be different size. You could be different stages of transition in your network speeds, but typically you've got 40 gig, 100 gig. And so you need an infrastructure that's going to be able to give you the range of access to these interface speeds. Garland provides that and gives you the normalization of connecting everything from 1 gig to 100 gig and beyond, and being able to bring that traffic up into the analytics layer. Next. So we can carry on. Yeah. So as we think about this traffic now that we're collecting and feeding up into analytics, the challenge we have is the volumes are massive. 1 hour of 100 gigabit traffic is terabits and terabits of data that you have to analyze and store and deal with. So the goal here is to optimize this traffic so that we're able to more effectively scale the upstream monitoring capabilities. So if you think of this in a building blocks perspective, I've got to get access to the data. That's number one. And you're going to create massive amounts of data by comparison to your environment. Even a small data center, it's going to be a lot of data. Now, how do I optimize that and scale the ability for Stamus and other tools to be able to consume this data to extract the intelligence from that. So we want to focus on the high value traffic. How do we deliver just the traffic that matters? Try to make intelligent, automated decisions that this traffic is either more monitorable, it's higher value, and take that low value traffic that we can't do anything with, and discard that or optimize that out of the equation. That's how we drive massive scale, and we'll give you some illustrations of that, to be able to deal with these exploding data environments that everyone is focused with. So we focus on what can we take out of that traffic that doesn't affect the monitorability or the integrity of the traffic that we're monitoring. Next. So what we want to do is really think about how do we optimize this traffic. First stage is you've got to build the visibility infrastructure, and that's where the Garland architecture, from the tap side to the aggregation layer, smart taps, being able to do active tapping environment for security and inline requirements, that gives you your core accessibility to all of this traffic. What's new within this equation is how do we optimize that traffic in a couple of ways, whether we need to do typical smart services like decapsulation, removing of headers, packet slicing, the typical smart services. NetQuest and Garland partnered together. We provide the intelligence services component at NetQuest to the Garland infrastructure. So Garland provides the aggregation piece. They leverage the NetQuest packet services broker to do the optimization. And then next, we would then feed that optimized traffic into the Stamus environment. And you can deliver this to your full range of tools. So Chris's point earlier, the investments that you make here for the first two stages of this architecture are extensible to everything else you're doing, whether it be network performance oriented, security performance, security monitoring, DDoS monitoring. All of these other tools can receive that traffic. And in some cases, the Garland aggregation will also become a distribution layer to help deliver that. But the goal here is get the network coverage, get access to the traffic, optimize the traffic, and then deliver only relevant traffic to the Stamus probe and the upstream analytics. Next. What we do, and without going too deep from a technical perspective, but I'm sure some of you love the technical details, is take that traffic in, and as Phil called it, DPI, deep packet inspection, we look at every single packet in real time at wire speed and make decisions. We can do filtering at this stage based upon IP addresses, application types. You can make very specific decisions of traffic you want to see and don't want to see. Think of this as a policy that you define, just like you would do with a firewall. I want to focus on this traffic. And you can team this with threat intelligence feeds where you identify, oh, these IP addresses are high risk. These IP addresses are hitting us, just like in the Midnight Eclipse example. And now we want to filter that because I want to see everything coming from this origination point and deliver that traffic to the upstream probing. Second stage is going to do what we call gray list filtering, and that's where we'll look at encrypted traffic and optimize that and deal with how do we hand encrypted traffic up to the Stamus probe to make it more efficient. The goal there is, how do I scale that probe to do more and not have to spend its cycles and its processing power on stuff that isn't monitorable? The Stamus probe and the Suricata probe have this ability to do sensing and bypass certain traffic, but it's still got to hit the probe, and it's still affecting the overall performance capabilities of that. So what we optimize is encrypted traffic. I'll go a little bit deeper in what we do there. We look at things like streaming traffic. While that's important for performance monitoring, it's not important from a security perspective. Most streaming video, voice doesn't carry threats, so we don't need to look at that at a security level. Maybe we make a decision that certain types of traffic will go to certain tools and other types of traffic, or removing low value traffic to the security tools makes the most sense. The key is this policy and filtering capability to be able to do that in the value chain. Next. And so if we think of this in the context of encryption, that's one of the biggest challenges. 80 to 90% of network traffic today is encrypted, whether you look at it internal, outside in, inside out. The reality is more and more traffic is becoming unmonitorable. How do I get into encrypted traffic? Sure, we can think about decryption, and there are certain technologies. We all partner with Mira Security, who does decryption, but that decryption is dependent upon keys. And how we look at that traffic, it's mostly internal. I can't deal with the external traffic. So most of that can't be decrypted. 86% of page loads, according to We Encrypt, which is Google, are encrypted today. Other interesting facts, 70 plus, and you got multiple analyst reports that report all these different numbers. 70% of malware delivered into your environment is hiding in encryption. It's buried there, so it can't even be identified. So the key here is how do we inspect that traffic without decryption? Because a high majority, maybe 80% of the, 90% of the encrypted traffic can't be decrypted. It really is about fingerprints and other heuristics that we can extract from that traffic. Next. And that's where the optimization makes a huge play, because we can take that traffic in at the optimization layer, identify that it's encrypted, the type of encryption's there, be able to sort through all the traffic and say, here is what's monitorable. Here's what I can actually use, and deliver to the Stamus probe the right components, whether it's headers and handshakes, essentially the unencrypted parts of the traffic. We can take the encrypted payloads, which no one can do anything with. You don't want to store that in your packet capture infrastructure or store that in the Stamus probe. You want to be able to focus on what matters. So we can truncate and deliver just the relevant components. We can take all encrypted traffic, offload that, say, well, it doesn't matter, we can't do it. We can tie that to the pre-filtering based on IP addresses or type of service and say, this service we don't want to deliver up. And we can focus on the different types of encryption. So as you build this architecture out, if you need to decrypt, we can do that. We jointly, all of us, have a solution to be able to focus on decrypting the traffic that can be if you want to do that. If you don't, then how do you deal with parsing through that? Next slide. And being able to focus on what matters. But ultimately, what we're able to do with optimizations is dramatically reduce the amount of traffic that's being fed up into the probes. As an example, in this particular customer deployment, 80% of the traffic that was destined for the tool, for the probe, was not usable and was filtered out. And we delivered that down to 20% of the traffic and still maintained the integrity and the efficacy of the monitored traffic at the analytics layer. Next slide. So if we think and put this in the context of, certainly you can go and put in the probe infrastructure to do that. And Stamus has 10 gig, 40 gig, and even 100 gig probes. But how do I match that to what I need to monitor? And so if I put probe for probe, you're able to do that. And certainly that makes a lot of sense, but it becomes extremely expensive, and that becomes an obstacle to deploying the kind of visibility that you need to implement within your network environment. We have bypass features and all kinds of things we can optimize, but the goal here, that's fine, Mark, you can leave it on the next slide, is to optimize and reduce the amount of probes that are required, and that makes it more affordable and more budget-friendly to your environment. And it's not just going to affect the Stamus environment, it's going to affect the rest of your security tool infrastructure, the portfolio that you have from security and performance perspective. So we'll take that traffic in, we'll offload, be able to define these are the things that monitor. So if you look at the comparison between top and bottom, if I'm monitoring a single 100 gig link, TX/RX, full duplex means 200 gigs of traffic. No one's running at 100%, but just using that as an example, if I needed to do that, I need 500 or 40 gig probes to cover one link. And of course, you could do it with 100 gig probe, actually two, because you're really monitoring 200 gig of traffic. If I optimize that, and every organization will be different in the performance that you get as far as the optimizations. You could get more, you could get less based upon what you're monitoring. You could cover that 100 gig link with a 40 gig probe and still have headroom to cover more links. So it becomes a very smart infrastructure between the TAP and the aggregation layer, the optimization layer, to be able to scale your budget and scale your visibility to catch more as it crosses the network. Next slide. And so putting the optimization piece is really, it's all about traffic acquisition. and that's covered between the Garland infrastructure, NetQuest providing the optimization, and Stamus providing the analytics and the threat detection and all of those key pieces. We're going to give you traffic acquisition at scale, at capacity to support your network environment. The NetQuest piece will optimize that and ultimately give you the ability to have more visibility in more places across the network in a very cost-effective manner. Bill, you want to kind of wrap this together?
Yeah, so these will be my obligatory slides talking a little bit about Stamus Security Platform, just to give you an idea of what we do. So we mentioned, you've seen something similar to this earlier in my part of the presentation. So basically, what we're talking about here are Stamus Networks probes deployed across the network. And as you saw from Chris as well as Steve, how you can tap the infrastructure as well as being able to optimize that infrastructure to reduce the number of probes that you may need to get even east-west traffic, which is the much harder type of scenario. All of that data, whether that's in a public cloud, we do support running our probes in Google Cloud Platform, AWS, Azure. All of that is we are capable of doing, and we send the data up to a central server, and all of that data is pre-analyzed to a point and then sent to the central server for generating what we call declarations of compromise, or actually, threats on assets, things that you really, really need to look at. And I'll dive a little bit more into that as I move through here. But the bottom line is that Stamus Central Server also communicates directly with the rest of your security stack, whether that's a SIM, delivering data to a SIM where you work out of as your single pane of glass, or utilizing API calls to communicate with a firewall or an EDR vendor to contain a machine or things like that. So all of that is capable within the stack here. So really what we've done from a Stamus Networks perspective is taken 3 disparate network security tools, IDS system, a network security monitoring system, and NDR, and we've combined them into a single platform. So this hits your compliance need from an IDS perspective. It gives you all of the data that you would expect from a network security monitoring, all the protocol transactions and PCAP information, as well as the machine learning and network detection and response that really breaks things down and reduces the amount of IDS alerts, if you will, so that you can actually utilize your SOC team to their best abilities. It also even has a loop in there so that things can be trained as well. So what I mean by that is training of users. Finally, going to this next slide, I should say, one of the things that we really want to point out is the bottom portion of this slide. Now you can see this is the traffic coming in, and at this point it would be traffic coming in from NetQuest's optimized traffic going into the NSM and IDS solution, which is doing the deep packet inspection, correlating and automating, and then moving all of this to that declaration of compromise. So you can see here, we had 1 gigabit Ethernet over a week at a customer location. They generated 2 million IDS alerts, 7.2 billion protocol transactions. Those were prioritized in the center there to about 5,000 events, which then turned into 5 impacted assets with 2 declarations of compromise. So really pointing out the capability of reducing the amount of data. All that data is still available if you want to go back and you're doing your investigation, or you need it for forensic purposes. And then why the Stamus Security Platform? Optimized threat detection. That's what I was just showing on that last slide, right? Using multiple detection technologies, as I've mentioned before, so not just focused on one detection technology. We want stateful logic. We want rules and signatures. We want machine learning to be able to do all of these detections, as well as you can use your own probes or Suricata sensors within within the network. So we do support Suricata sensors being deployed. So if you have a large deployment of build your own Suricata sensors and you want to move to Stamus, we can make that really simple for you. And that could be something that happens, in a phased approach. Open and extensible, again, being able to send the data to third parties, as well as receive threat intelligence from third-party organizations. So you may have purchased some type of tool, some type of threat intelligence, and you can deploy that within the Stamus security platform. We do operate in air gap deployments. One of the other pieces of data that I always like to say is you have complete data sovereignty. All of our analytics happens within our probes and our Stamus central server. You own where they go. This is huge. We do for a lot of organizations to basically say, you don't have to send data out to a cloud in order to make it work. All of this stuff is you have complete sovereignty over where your data is being delivered. We have detailed evidence, as was mentioned before, with those 7.2 billion transactions. So you can utilize that information to get evidentiary and forensic type data during your investigation. And we've built for enterprise scale. So as was mentioned before, we do have 100 gigabit per second probe. If you are doing full duplex 100 gigabit, you may need 2 of them, but we can hit those types of throughputs and do all of our analytics still on-prem. Right. All right, so some of the key takeaways. Network visibility is crucial to the enterprise security, right? I think we've covered that, and hopefully that's what you came away with. East-west traffic can uncover threats, such as lateral movement that other systems might miss, and how we can do east-west traffic at a decent budgetary number for you, right? With the team here, with Steve and Chris and Stamus, and putting that architecture together. With the combination of network taps and traffic aggregation, as well as optimization to get the information into Stamus for monitoring east-west traffic with additional intelligence, right? We do offer specific lateral movement type of intelligence here at Stamus Networks to put into the analytics platform, as well as the solutions provided by NetQuest and Garland. We really want to make it cost effective for you. So I know we're coming up on the top of the hour. We do have a few questions that have come in. I think Kim is going to get us some of that before we hang up here.
Yeah, I think I'll take, thanks, Phil. I'll take just a very short time here to just mention that we are going to be sending out an email early next week that will include some additional resources that you see here on the screen. We have some white papers and solution briefs. You'll also get these slides in that email. And so there's a couple of QR codes that you can use that will take you right to our resource library and a lot of other information that we have if you're interested in reading that. So I'll give folks a little bit of time to type in their questions. We do have a few already. Again, just use that Q&A function, and then we'll try to move through these as quickly as we can. All right, Phil, so first question for you. So does the lack of being able to update a hardened device, so for example, a medical device, create more issues for the end user or organization that produces it? And then also, if it is the organization, is that due to regulatory certification or another reason that it would have that impact?
Yeah, and I'm actually working with a couple of customers right now on this, and it actually is an issue for both the organization as well as the end user of the appliance, right? Basically, what this does is it adds a layer of certification, as you mentioned, especially on the medical device front, where these things could be running Windows, for instance, and they are only certified at a certain level of Windows, and you can't add anything to those devices, right? So if we're talking about an MRI or some type of medical device like that, you can't actually add any third-party tools to that due to the certification that's necessary. So this does, produce issues for both the end user and the organization that's producing that equipment because they're not able to fully protect everything and get up to the latest versions of the operating systems and things that they need. So it actually kind of covers both, and it is impacted in both locations. So
Thank you. And then Chris, I think this one will be for you. Are taps
Yep.
better than placing IPS between critical components of the environment for the monitoring of the east-west traffic?
Yeah, so a couple things on that. When moving to east-west, generally we're looking at a lot more links we have to deal with, and so fundamentally trying to put an IPS into all those links could be very challenging. So taps can be a much easier way to get out of band monitoring, but we do have active taps that are called bypass taps that actually work in conjunction with intrusion prevention systems. So not only at north-south, if you're looking at deploying intrusion preventions, we can actually utilize what's called a bypass tap that gives you the ability to take a IPS offline or inline, as well as also do the passive tapping. So we have some technology that incorporate packet broker and bypass taps, so you can deploy your IPS, but also send a copy of the traffic to your out-of-band tools and send it to Stamus. So with east-west, though, it could be very challenging. If you have 60 links and you want to put in an IPS on all of those, it can be very challenging. But if you do want to put intrusion prevention at that layer, we highly recommend utilizing bypass taps to ensure network uptime and be able to take those offline, inline, be able to maintain them and support them. So I hope that answers the question. And obviously, if folks want to discuss things in more detail, we're available. And obviously, Kim, thanks for putting ways to get contact as well.
Okay, excellent. Thank you. So let's do, I think I have one more here. Hang on. I think this is more for Steve. Sorry, I'm just scrolling through here. Oh, okay. So how do we monitor a combination of 1, 10, 25, 40, and 100 gigabit links?
That's a great question, because that's a big challenge. Most people have multi-speed environments within the network between a combination of legacy servers that don't support higher speeds, legacy tools upstream that maybe can't take in the higher speed connectivity. And that's really where the combination of the Garland infrastructure and being able to tap and access all of that different traffic speeds, and how we can optimize that to feed it up. So we can create really an environment that deals with the mismatch of different links at different speeds, collecting all that in, normalizing that traffic, and then being able to feed it into the upstream tools. So collect a bunch of 1 gig links, for example, especially in an OT or an IoT environment, feed that up into a single probe, right? Where we can take that traffic, aggregate it, load balance it, deliver it to a single probe, or take a 100 gig link, break that up and deliver it to multiple slower speed probes. And the optimization layer within that makes that traffic even more manageable. So I'll just kind of reference what Chris had said. There's a lot of detail in building this visibility architecture in these pieces. Like, do I tap? Am I doing IDS as detection or IPS as prevention, active versus inactive? We certainly can have a conversation with any of you that want to go in deeper detail to look at your specific requirements. There's no one size fits all here. We can provide an architectural blueprint, but it has to be adapted to your environment and how your data is moving across the infrastructure and the users.
All right, great. Thanks so much, Stephen. So we're a few minutes over, so we're going to go ahead and just close things out. So if you had any additional questions, of course, you can reach out to us. That information will be available in the email that you will receive next week. And thank you, everyone, for joining us. Thanks to Chris and Stephen also for joining us as well. And we look forward to catching up with folks later.
excellent. Thanks, Kim,
Thanks
for
so
hosting.
much. Okay,
Thank you,
great.
Kim.
Have a great week,
Thanks,
everybody.
Bill.